We'll continue with the next two questions on the page. Now, if you remember earlier, I referenced that there's kind of a shortcut we can use here with the decimals, and you'll see the same is true when you look at the fractions video. There's a different type of shortcut there. It may not actually be any less writing. As a matter of fact, it may actually be a little bit more writing. But what it will probably do as you go through this is it will probably make the question a little bit cleaner, a little bit easier to work with, because there's not going to be so many decimals that we have to worry about carrying the correct way. So what you want to do with the shortcut here is you want to identify the longest decimal. In this case, this is the 2.12. And what I want to do is, since that has two places after the decimal, I'm going to, in every part of the equation, move every decimal 2 places to the right. So, for instance, in this 0.2, when I kick that twice to the right, now all of a sudden that's going to become negative 20. And again, that has to be done in every part of the line here. Now, where we run into problems, and as you can see I'm leaving a quick blank here, is that h. Remember, h there would actually be the equivalent of 1 times h. All right? It has to also be moved there, even though there is no apparent decimal. So I can't just leave that as h. It has to be written as 100h. Again, when I move that twice to the right, 2 empty jumps, just as I've done in the other parts. And as you know from past experience, those fill in with zeros. Now, as you can see, what that did have the effect of doing, though, however, is it did get rid of all the decimals for now. The decimals will return when we get to the answer part, but for now, the decimals are gone. It may make the problem, again, look a little bit cleaner to some people, might make it easier for some people to work with. Okay, so at this point now, we have a distributive property question. So you've got a couple different options on how you want to proceed here. You can, if you want to at this point, distribute the negative 20 through both parts, which is exactly what I intend to do. You could, if you wanted to right away, also divide by negative 20. That will cancel this out right here, and you'll have 860 over negative 20 to deal with. But because we're trying to get good with distributive property, I'm going to carry this through to both parts using that distributive property. So I've got 212 times 20 there. That's negative 4240. And here I've got the 100 times the 20, which is, of course, 2,000 with the h. And notice it would be minus a negative through the process of multiplication. Well, minus a negative is really the same as addition. So even though it was minus before, now it's plus for that basic rule. And it's still going to equal 860. So we say to ourselves, okay, we want to keep that variable on the left side of the equal sign, and that 860 is a number that's on the right side of the equal sign. 4240 and the 2000 are both going to have to move. Keeping in mind that the thing that's directly connected to the variable, in this case 2000, is going to be the last thing I touch. So we're going to look at moving 4240 first. Well, notice 4240 there is a negative number. So when I talk about the opposite this time, I'm talking about positive. And positive looks a lot like addition. So the way I'm going to do that is I'm going to add 4240 to both sides. This negative 4240 plus 4240 washes each other out and leaves me 2000h. And as you can see, that's equal to 5100. And then at this point, I'm going to take and divide out the 2000. Again, it's just a one-step equation I have left. It's multiplication, so I'm doing the opposite, which is to divide. So I'm going to do 5100 divided by 2000 at this point. 5100 divided by 2000 is 2.55. And that's what h equals. And again, we can check that, plug it back in, do order of operations on the left side. Once I do all that, the left side should be the same thing as the right side. Now, the question on the right there is also a little bit different. This one is a giant kind of fraction or division problem. You've got a few different approaches you can use here. You can, if you want to, undo this division right away in this problem, or you could put this over 1 and cross multiply. It doesn't really matter which technique you use. You'll get the same answer either way. But let's jump into this here. We're going to start off and we're going to say to ourselves, okay, the things that are right about this are the variable k. The variable is on the left side of the equal sign, and also my 0.22, which happens to be negative, that's a number, and it's off to the right side. So both the 3.7 and the 9.8 are going to have to move here. Again, there's two techniques here. You can put the 0.22 over 1 and cross multiply, or you can just multiply by the 9.8 right away, which either case would get this to look like just a regular old problem, more like what we've seen in the first three that we've done. I'm going to go ahead and put this over 1 as I've suggested and cross multiply. So on this one diagonal, I've got k plus 3.7 times 1. Now sometimes that would present more like distributive property, but because we're multiplying by 1, that's just k plus 3.7 still. Think about it. If it's just said 4 times 1, it would still just be 4. Well, it doesn't matter that it's k plus 3.7. I'm still multiplying it by 1, so it's still k plus 3.7. On the other diagonal, I've got 9.8 times the 0.22, and again, that 0.22 is negative, which is 2.156. And again, that result will be negative because one of the numbers was negative. Now, we can, at this point, if we want to, use the shortcut that we saw on the problem there that's still on the screen to the left. We could have actually done it right in the beginning, but let's go ahead and do that quickly. My longest decimal here is the 2.156, which has 3 places after the decimal. So every decimal is going to get moved 3 times to the right. Now, did you see what I did there? Did you see the mistake I made there? I didn't do it for k. That's a mistake. Remember, as we talked about in the problem on the left, this is really the same as 1 times k. And then we'd move it 3 times to the right, just like I did for the other parts. Again, when you do the decimal move technique, it's got to be moved every single time. In this case, it's the equivalent of multiplying by 1,000. But again, all it really does is it moves the decimal. So this is 1,000k plus 3,700 equals 2156. So, now we look at this and we say k is still in the correct spot. It was on the left in the beginning. It's still there. And 2156, my number, is on the right side. That's good. Of looking at the two things that are wrong, the 1,000 and the 3,700, we know that the thing that's directly connected to the variable, as you can see I'm highlighting 1,000 there, right, that's going to move last. So 3,700 moves first. Again, when I want to move something to the opposite side, I do the opposite. And since 3,700 has an addition sign in front of it, the opposite is going to be to subtract. So I've got 1,000k equals negative 1,544. And at this point, this would be a multiplication problem to be solved by division. So I'm going to divide out 1,000. And when I take that and divide out 1,000, that's, of course, negative 1.544, or k is equal to negative 1.544.